I am Anil Kumar. Welcome to my series on discrete functions. We are solving a test paper. Here is part 2, in which we are going to discuss question number 9 to 13 from this test paper. Have a good look at these questions. These are application and thinking questions. So let's begin with question number 9. In an arithmetic series, T10 equals to 33, S16 equals to 432. Find the first three terms. So in previous examples, we were given the series and we were finding the sum. Now we'll kind of do the reverse. We are given a term number, which in this case is T10, and that is equal to 33. We are also given sum of 16 terms, and that is 432. Now this is arithmetic series we're talking about, correct? So in arithmetic series, the formula for the terms is Tn equals to a plus n minus 1 times d. So we can substitute these values. N is 10 for us and Tn is 33. So we can write this as 33 equals to a plus 10 minus 1 times d. So that gives us an equation which is 33, equals to a plus 9d, right? So we'll call this as our equation 1. Let me rewrite this as 33 equals to a plus 9d. Second, we'll get from the sum. For the sum of 16 terms, in terms of a and n, the formula is S of n is basically equal to n by 2 times 2a plus n minus 1 times d. Now here S16 means there are 16 terms and it is 432. So 432 equals to 16 divided by 2. Replace n with 16, right? So 2a plus 16 minus 1 times d. So that is, we can simplify this. So we can just say 432 divided by 16 divided by 2 is 8. So we can divide this by 8 is 2a plus 15d, right? Dividing by 8, we get 8 times 5 is 40. 32 is 4. So 54 is 2a plus 15d, right? So this is our equation number 2. So let's rewrite this equation here. So we have two equations and two unknowns we can easily solve. So we have 54 equals to 2a plus 15d. We can multiply the first equation by 2. So we get 66 equals to 2a plus 18d, right? Getting the equation 3. And now if we subtract one from the other, so if I do equation 3 minus equation 2, this minus that, so we get here 12 equals to 2a cancel, and 18 minus 15 is 3d, or we get 12 divided by 3 as d, so d is 4 for us. So we have the value of d, which is 4. Now, since we know what d is, we can now find the value of a using one of our equation. Let's substitute this in equation 1, which is 33 equals to a plus 9 times d is 4. So we get here 33 minus 9 times 4 is 36 equals to a, or minus 3 is the value of a. So we get here a as equal to minus 3 and d as equal to 4. Now we can always find the first three term of the arithmetic series, right? So it is the first term minus 3, keep on adding 4. So when you add 4 you get plus 1, then 4 means 5. So these are your first three terms. Correct? So that becomes your answer. Is that clear to you? So that is how you can actually solve this question. Now let's move on and take up question number 10. Question number 10 is, this Indian snack bar finds its profits from the sales of samosas increase by $25 each day during the 10-day of Toronto International Film Festival. Find the profit for this duration if the profit for the first day is $80. So we are given first day profit. So let's call this as A, which is $80. It is increasing by 25 each day. That means D is 25. We are already given that this is constantly increasing by 25. So basically we are working on arithmetic series, right? And now we know that total number of terms are 10 since it is for 10 days, right? So we know n is equal to 10. We need to find the profit for this duration if the profit for the first day is 10. So profit for n days will be S of 10, correct? So we want to find the profit, which is sum of all these profits starting with $80 on the first day, right? So sum of profit formula can be utilized. So sum of arithmetic series is n by 2 times 2a plus n minus 1 times d, right? We can substitute the known values to find this sum of first 10 terms starting with 80, right? So n is 10, so we get 10 over 2. 2 times a is 80 plus n is 10, 10 minus 1, and d is 25. So we get here 5, 160 plus, well, 250 minus 25 is 175. So that becomes our answer, right? So we get 5, 7, 6, 13, 3, 1, 3, 3, 5. And multiplying by 5, 5 times 5, 25, 2, 15 and 2, 17, 1, 16, 75. And the profit is in dollars. So our answer here is $1675. Correct? Question number 11. Expand 4x minus y to the power of 5. Now you could use binomial theorem here. So there are two options. You can use binomial theorem or you can use Pascal's triangle. Now I find it simpler to use Pascal's triangle, so we'll go with that. So beginning with 1, we'll just make our structure 1, 1, and then it just continues. So we have 1, 2, 1. So 1, add the previous 2, right, to get the next number, correct, in this series. So 1, 4, 6, 4, 1. So this is the fourth row, and now we are looking into the fifth one. So 1, 5, 10, 10, 5, and 1. So these are the coefficients, right? So using these coefficients, we can always expand, right? So let's figure this out. We have 4x minus y to the power of 5. So what we get here is the first term coefficient is 1, but the power is 5. So we get here 4x to the power of 5 plus, now we get coefficient of 5 times 4x to the power of 4 and minus y to the power of 1, right? Next coefficient is 10, 4x to the power of 3 minus y squared, and then we have again 10, so let's write down here, plus 10 is the next coefficient, and we have 4x squared times minus y cubed. Their sum will always be 5, okay? Then we have 5, we have 4x and minus y to the power of 4 plus 1 is the coefficient now, and we get minus 5 to the power of 5, correct? So we can actually expand and simplify this. So let's calculate. So we have 4 to the power of 5, which is 1024, x to the power of 5, plus we have 5 times 4 to the power of 4. So 4 to the power of 4 times 5, 1280, right? So we get 1280 x to the power of 4, and minus y. So we'll write minus y next time. Now here we have plus 10. So 4 cube, 64, 640. X, and this becomes y square, which will be positive. Then we have plus 10 times 4 square is 16. So we'll do 160 x square minus y cube. Okay. And then we have plus 4 times 5, 20 x y to the power of 4. And then we have minus y to the power of 5. So let's correct this sign here. So we get 1024 x to the power of 5 minus 1280 x to the power of 4y, and then we have plus 640 x y this should have been cube, right? So let me check if I did this right. We have 460, yeah, 4x cube, right? And then we have a square. So we'll write plus, or rather minus, because this minus will be minus 160 x square y cube. That will be plus 20 x y to the power of 4 minus y to the power of 5. Okay? So when you expand, this is what you will get. Alternate numbers should be negative since you have minus y there. Perfect. And the sum of all these exponents will be 5. So here I think I missed 640 y squared. Okay. Sum will be 5, right? So it's good to check and rewrite. Okay. Question number 12. Question number 12 here is, the first term in a sequence of number is t1 equals to 5. The terms that follow are defined by the formula tn equals to, is given tn minus, so we'll take tn minus 1 to the right side. So I'm writing this as tn minus 1 on the right side, and then to that we are adding 2n plus 3. So I'm taking this to the right side and then writing the nth term in terms of tn minus 1 plus 2n plus 3. We need to determine the value for t50 from this particular sequence, right? So we are given a recursive formula, right? So we are working with recursive formula. So one method could be that let us find the other terms. So what is t2 equals to? So t1, which is 5, plus 2 times 2 plus 3, which is 2 times 2 is 4. 4 plus 3 is 7, right? So we get 5 plus 7, right? Which is 12. Now t3 will be 12 plus 2 times n, which is 3 for us now, plus 3, which is 12 plus 2 times 3 is 6 plus 3 is 9, right? So you see this is also stepping up by 1, and we get here 21. T4 will be 21, the last term, plus 2 times 4 plus 3, which is 21 plus 8 plus 3 is 11, and you get 32. And we can write the last term as 25. 32 plus 2 times 5 plus 3, which is 32 plus 10 and 3 is 13, which is 45. Correct. So likewise, this is the series which you get. Now we need to determine T50. How do we figure this out, T50? Well, we can look into the trend and then find the value. So since it is a quadratic expression, right? Since it is a quadratic expression, let's find a general term. So basically, let's find a general term. So we can say general term Tn will be, since it is a quadratic expression, we'll write n squared plus b times n plus c, correct? Now we can substitute n as 1. So this is for n equals to 1 and this is for n equals to 2, correct? So if I substitute n equals to 1, I get t1, which is 5, equals to 1 plus b plus c. That is one of our equations. And if I substitute n equals to 2, t2 is 12, so we get here 12 equals to 2 square is 4 plus 2b plus c, right? So that becomes our equation 2. Now if I take away one equation from the other, in that case, what do I get? So we get minus 7 equals to, this is minus 3, and here we have minus b, and c vanishes. So we get b equals to 7 minus 3, which is equal to 4, right? So that is our equation 3. Now since we know what b is, we can use the equation 1 and then find what c could be, right? So we can use these two and we can find what c could be. So from here we know 5 equals to 1 plus 4 plus c. So that implies 5 equals to 5 plus c, and that gives you c equals to 0. So that becomes our equation 4. So we know now both b and c, and therefore we can say that the nth term is basically equals to n squared. Value of b is 4 plus 4n, right? And c is 0. So that becomes our general term. Is that clear to you? Now from this general term, we can find what T50 is, right? So now let's calculate what T50 is. So T50 will be 50 squared plus 4 times 50, correct? Which is 2500 plus 200. So that is 2700. So that becomes our answer, correct? So we have T50 equals to 2700. Now this is a very interesting and useful example. I'd like you to once again go through this and then look into the solution of the last question here, which is question number 13. The first three terms of arithmetic sequence are, we're given numbers as 2x minus 5, 5x plus 3, and x squared plus 2. Find the values of x and calculate the values of the first three terms. We have to find what x is, correct? And we are given arithmetic sequence. Okay. Now that means we have a common difference, right? So we have common difference d. So d basically will be 5x plus 3 take away 2x minus 5, correct? So we get 5x minus 2x as 3x, and 3 plus 5 will be 8. So we know d is 3x plus 8. So that really means that if I add, so we have this to this is plus d, right? So here also when I move, I have to plus d to get x squared plus 2. Now that really means that x squared plus 2 should be equal to 5x plus 3 plus d, right? Which is 3x plus 8. So we have x squared plus 2 equals to 8x plus 5 and 8 is 11. And we have a quadratic equation, x squared minus 8x plus 2 minus 11 equals to 0, or x squared minus 8x plus 9, minus 9 equals to 0, right? So if I solve this equation, we know the value of x. So the equation to solve is x squared minus 8x minus 9 equals to 0. 9 times 1 is 9. So we could factor this as x minus 9 times x plus 1 equals to 0. So that gives us two values. One of the value here is x equals to 9, and the other value is x equals to minus 1, right? So we have two values for x. So that means we can actually have two different series, right? So let's write down first series for x equals to, let's say, 9, right? So if I use 9 here, what do I get? My terms will be 2 times 9 minus 5, which is 18 minus 5 is 13, correct? And the next term will be 5 times 9 plus 3, which is 45 plus 3 is 48. And then we have 9 squared plus 2. 81 plus 2 is 83, right? So that becomes first three terms, you may have to check whether do you have the constant d or not, right? So let's also calculate this value. Well, so what do we get? Difference, right? So d is equal to 48 minus 13, so 5, and 4 minus 1, 35, correct? So here also, if I check, it is d equals to 35, so that works, correct? That's what. Okay. Now, for x equals to minus 1, let's substitute minus 1 and get the three terms. You can also find d, substitute that in the first term. You could do that. But I'll prefer to straight away write down minus 1 here, right? And then check. So it is minus 2 minus 5 is minus 7. 5 minus 1 plus 3, which will be minus 5 plus 3 is minus 2. And then we have minus 1 square plus 2. So 1 plus 2 is 3. Now let's find d here. Is it constant or not? So that is a good check, you know. So you're adding 5 to move on. That is correct. So that is also correct. So these are the three terms which we have got. So we can now write down our answer that the terms are 13, 48, 35, or we could also have minus 7, minus 2, and 3, correct? So with this, we have complete solution to our test paper. I hope you understand and appreciate it. So these were the 13 questions which we took. The very first question was an excellent question, and then some in between were very tricky. Once you go through them, I hope you'll be well prepared for your test. Share your comments. That will be good for us. Also, share my videos with your friends. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.